to get the hang of it. Very, very easy to go through. Now, question B, two more. Question B asks, again, whoever visits a city most gets all the votes from that city, and if the two candidates visit the city the same number of times, then the votes from that city are split equally. However, now say that if neither candidate visits the city, then the people in that city feel unloved and do not vote for anybody. Same thing as this. Quite literally same thing. Except now, in reality, the only payoffs that changed are this one and this one. Because it says, now that if neither candidate visits the city, then the people in that city feel unloved and do not vote for anyone. There are only 2 times or 2 strategies where candidates do not visit a city. Here, when they visit Alberta 3 times and Baja none, or when they visit Baja 3 times and Alberta none. In that instance, here, keeping in mind that a city will split when visited equally, Alberta, which is worth 120 votes, gets split into 60 and 60, and Baja, which is worth 180 votes, gets split into 90 and 90. So again, same thing. Literally the same thing. Nothing changed other than these 2. However, our strategies, still have to go through them, because they could have changed. First strategy, again, same system as above. WD weakly dominates, SD strongly dominates. 1B weakly dominates 1A. Let me delete this. 1B weakly dominates 1A. We have 180 over 60, 150 over 120, but then you have 2 ties here. Here you have 2C weakly dominates 2B. 150 is less than 180. 120 is less than 150, but you got a tie here. One C, the weakly dominates 1B. 180, tie. 150, 120, 150 is greater, tie. 120, 120. So you have 1C, weakly dominates 1B. 2C, weakly dominates 2A. 150 is greater than 120, but 120 and 120 are a tie. Oh yeah, next part. Thought I was spoiling something. So this is what we're left with our prediction. Could be, again, this is not saying that these are going to be the, decisions or the outcomes of this game. Rather, this is what most likely will occur when candidates start to look at their strategies and what their strategies actually will provide, what results they'll provide. This is our bubble of prediction, what we assume might happen. To find our completely forgot. Pure strategy Nash equilibrium. We're going to do the same thing that we did up there. When candidate 2 takes this strategy, what is candidate 1's best payoff here? Again, there's a repeat, 180, 180, 180. Here, 180, 180. Here, here, we can delete, or we'll leave it there. 180. And here, 120, 120, 120, 90. 120, 120, 120. So now take a look at candidate 2. When candidate 1... Oh, okay. That's good, yeah. When candidate 1 does this, what is candidate 2? Oh, that's better, yeah. Candidate 2, what is their best option? Candidate 2, 180, 180, 180. Here, what is their best option? 180, 180. Here, what is our best option? 180. And here, what is our best option? 120, 120, 120. So we have a good amount of Nash equilibrium. Oh, completely forgot this one. You have, again, did the same thing. 1D and like 1D, 1B, 1C, 1A, and 2A, 2B, 2C, 2D. So we have 1D, 2A, which is basically Baja 3 times no Alberta, Alberta 3 times no Baja. 1D, 2B, 1D, 2B, 1D, 2C, 1A, 2D, 2D, 1B, 2D, 2D, and last but not least, 1C, 2D. Right here. And now, last question. Now that we have votes from a city, completely read that wrong. Now that votes from a city are split between two candidates proportionally according to how many times each candidate visited the city. So, it's kind of like an example. Let's say that candidate 1 visit Alberta twice and Baja once. Candidate 2 visits Alberta 3 times and Baja none at all. Alberta got a total of 5 visits. Baja got 1 visit. Alberta voters see 2 visits from candidate 1 and 3 from candidate 2. Total of 5. Total of 5 visits. So 2/5 of Alberta voters, which is 2/5 of 120, will vote for candidate 1, and 3/5 of Alberta voters, 3/5, 120, basically whatever is left over from here, will vote for candidate 2. Baja voters only saw 1 visit from candidate 1, no visits from candidate 2. All Baja voters vote for candidate 1. So candidate 1 is going to receive a total, because they visited Baja once, and Alberta 2 out of the 5 times, they'll be getting 180 from Baja, because remember that Baja is worth 180 votes plus 48. This is 48. Plus 180 to 28. And then candidate 2 will be receiving only this. They did not visit Baja. They'll be only getting 72 votes, which from the 3 out of 5 times. So yeah, that is a new basis of how we're gonna find our payoffs for this problem. Well, again, I went ahead and did the payoffs already because they're taking a bit longer. So that instance that we saw up here of candidate 1 at Alberta twice is right here. Candidate 1 at Alberta twice, Baja once, and candidate 2 at Alberta 3 times. Right here, and Baja not at all. So again, there it is, 228, 72. And once you start, gets to a point, your chart gets to a point where once you start to, get to certain ones, they are basically the opposite of each other. Like here, when candidate 1 visits Alberta once and Baja twice, opposite of when candidate 2 visits Alberta once, Baja twice. It's the same payoff. You see, candidate 1 received 210. Canada 2, 210. In this instance, and in this distance. Because these are the same. Hope that didn't confuse it. That's just a trick I like to see. Or I like to use. Because I didn't show my calculations, but this took a bit of a time. Not super long, but you know, you have to really just pay attention to how many times are visited throughout each. Like, for instance, here. We have 3 times from Alberta, 3 times in Alberta from Canada 2, 3 times in Alberta from Canada 1. So Alberta was a total of 6 times. 3 of the 6, which is basically half, of the vote goes to Canada 2, and the other half goes to Canada 1. Because Alberta's 120, one person gets 60 votes, the other gets 60 votes. Pretty straightforward. You basically just total the amount of times each, like here, we can do 2C and 1D. Baja was visited 3 times here, 2 times here. So a total of 5 times. Alberta was visited once here, no here. Because Baja was visited 3 and 2, which is 5, Canada 1 will receive 3 out of the 5 votes, or 3 out of 3/5, 3/5 of the 180 votes, which is totals to 180. Because it did not visit Alberta, get nothing from Alberta. Again, because Baja is 180, you would just subtract that from 180 and you would get 72. So then because Canada, or again, that is 2/5 of 180, that is 72. So keeping that in mind, because Canada 2 visited Alberta once and Canada 1 never, they would get not only the 120 from Alberta plus the 72 from their proportion of Baja. And again, that goes for everything else. That's the same layout for all of the other payoffs. So you'd get, yeah. Not going to go through all of them because that would take a really, really long time. But yeah, once, like, how here you would have, right here. This 192 from when they visited Baja 3 times and Alberta none. It's right here. This 18 from when they visited Alberta once and Baja twice. It's right here. So once you reach a certain point in your charts, I realize this with a lot of other problems, you kind of you're able to interchange values. So for our iterative elimination, we are going to start with candidate 1. 2B, we started with candidate 2 here. 2B strongly dominates 2A. 220 is more than 60. 150 is more than 72. 140 is more than 90. 210 is more than 120. 1C strongly dominates 1A. 90 more than 72. 108 more than 90. I looked at the wrong one. Sorry. 160 more than 72. 150 more than 90. 192 more than 20. And save some time. 2B weakly dominates 2C. So, 150 less than 160. 140 less than 150. 210 more than 192. Oh, I'm so sorry. I meant the other way around. So 2C weakly dominates because you have 160 more than 150, 150 more than 140. And even though this is more than that, 2 beats 2 out of 3 beats 1 out of 3. So you have 2C weakly dominates 2B. This one, 1C strongly dominates 1B. You have here, 150 is more than 140, 192 more than 165. And excuse my error here. I'm pretty sure I meant, here, we can do that together. So, taking a look at 2C and 2D. 150 more than 108, 192 more than 90. So C strongly dominates 2D, and then 1C strongly dominates 1D. You have 150 greater than 108? Yes. So 1C strongly dominates 1D. Your prediction would be, where is it? This. And for Nash equilibrium, you would simply do what we had just been doing. Taking a look here at this row, what's the greatest payoff around these columns? 228. Here, 160. Here, 150. And here, 192. Now here, this, 228, this, or this, 160. This, or this, 150, and this, or this, 210. So here is your Nash equilibrium. Alberta one time, Baja twice. Alberta one time, Baja twice. And this is how you lay out your Nash equilibrium. You lay out the strategies. And then this is player 1, count it 1, player 2, count it 2. Let me just mark up here. This is our prediction. Again, does not mean that is what is going to happen. Rather, that is a probable situation. And that's it. Thank you so much for watching. Hope that tutorial served you well.